using the integration to prove that delta of at is equal to 1 over absolute value of a delta of t, hence show that delta of omega is equal to 1 over 2 phi delta of f, where omega is equal to 2 phi f, and show that integration negative infinity to infinity phi of t delta of at dt is equal to 1 over absolute value of a phi of 0. Okay, now first I'm going to start with this one. Delta of at is equal to, we want to prove that delta of at is equal to 1 over absolute value of a delta of t. We have to start considering this equation. This is given by integration negative infinity to infinity phi of t delta of at and dt. So here what we are going to do is we are going to do a u substitution. To do the u substitution, what we are going to do is we are going to take that okay, in the integration explanation. Okay, let's write the explanation. So we want to show that this integral evaluates to 1 over absolute value a phi of 0. Okay, if we show that, then this become true. Now to show this one, what we are going to do is we are going to do a u substitution for this. So here this is the integration I'm going to deal with, and for this one what I'm going to do is instead of at I'm going to substitute u is equal to at. So if I change u is equal to at, then automatically this t becomes u over a, and then this dt become du by a as well. So if we write the new integration in terms of u, this is going to become negative infinity to infinity, then phi of, instead of t, you rearrange this one in terms of t, that's u divided by a, and then delta, instead of a we are going to have u over t, but at is equal to u, so you can just, instead of at you can just put u right here, and then instead of dt we are going to put du by a. Since we are integrating this one with respect to u, anything except u is going to be a constant, so this a we can move in front of the integral sign, 1 over a. And also we have to know one more thing, that when we are dealing with the impulse function, it only happens at 0. So any other value doesn't matter, like negative infinity to infinity, we only gonna deal with 0, because other values for the impulse function is going to be 0, so we cannot integrate that. So only at 0 is this going to exist. So instead of u we can put 0 here. So if we put 0, this is going to be phi of 0, and I bring the phi of 0 to the front since the u value is gone, and then we are going to have negative infinity to infinity, and then delta of u du. Okay, and if you integrate an impulse function, that is 1, so this is basically 1 over a phi of 0 times 1, which is this thing. So we prove that this integration is equal to this by doing the u substitution. So if we prove that, then is automatically prove this delta of at is equal to 1 over absolute value of a delta t. Okay, so we can also write this one as absolute value as well, doesn't change anything. So we can say therefore integration of negative infinity to infinity phi of t delta of at dt is equivalent to 1 over absolute value of a phi of 0. Okay, which is equivalent to 1 over absolute value of a delta of t, because delta t only exists at 0, so it's automatically prove that. So delta of at is equal to this, but it's very okay, so we prove that one. Now let's deal with the second one. For the second one, we are going to use this equation we derived. I'm going to go to another page. Okay, so what we had to prove? We had to prove that delta of omega is equal to 1 over 2 phi times delta of f. 1 over 2 phi times delta of f. And here we know that omega 2 phi f, omega is the angular frequency phi f. Okay, so to do this, first we are gonna set a is, first let's set a is equal to 2 phi in this equation. Integration negative infinity to infinity phi of t delta of a, instead of a we are gonna replace it with 2 phi. So this one becomes 2 phi t dt. Let's do that here. Integration negative infinity to infinity, then delta of t, and then we have that's phi of t, and then delta of at. Delta of at, instead of a we are going to replace it with 2 phi, then we have t, then dt. Okay, so if we integrate this one, what's going to happen? As you can see, this is like, if you look at this one here, the value in front of the t is the coefficient, the coefficient in front of the t is 1 over the absolute value of that. So here coefficient in front of t is 2 phi, so this is going to be 1 over 2 phi. Okay, the absolute value, therefore it's going to be positive anyway. So 1 over 2 phi, and then by delta function, when we integrate, this is the function. So here whatever the time we have, like we have to replace this one with, if 2 phi t is equal to 0, then therefore t is going to be equal to 0, because 0 divided by 2 phi, that's also 0. So here the time is 0, so this phi is going to be 0, because that's the time the impulse function is going to happen, phi of 0, and then integration of the impulse function, that's 1. Multiply the that one by 1, you will end up deriving this. Okay, but this is not what we had to prove. We had to prove delta of omega is equal to 1 over 2 phi delta of f. So to do that, what we had to do is we had to take the omega into place. So now okay, since omega is equal to 2 phi f, since omega is equal to 2 phi f, we can rewrite right delta of 2 phi t as delta of omega t. Okay, so instead of this 2 phi t, now we are going to put omega t for that. And also we can, to simplify the equation, I'm going to put x is equal to omega t. So this is similar to u substitution. So we can do the integration easier. So integral negative infinity to infinity phi of t delta of 2 phi. Instead of 2 phi t, I'm going to put omega t right here, and then dt. Now if we replace, to make the integration easier, I'm going to do the u substitution kind of thing. Since we already used u, I'm using another variable called x here. X is equal to omega t, so it's going to replace everything here. Negative infinity to infinity, then phi. Instead of t, if we rearrange this one, this x over omega, so that's the one going to come right here. And then delta of omega t, instead of omega t, I put the x right here. And if x is equal to omega t, then dt is going to be dx over omega. Okay, and since we are integrating this one with respect to x, anything except anything except x is going to be a constant, so we can move this omega to the front. So this is going to become 1 over omega, and this impulse function only happens when the time is equal to 0, because we don't have any shift or anything. So this impulse function is going to happen at 0. So anything except 0, we are not going to have any value. So we can replace this x with 0. So that one make the phi to be phi of 0. So if that happen, then we are going to have integration negative infinity to infinity delta of x dx. And if you integrate an impulse function, that's equal to 1. So this is the final answer for this one, is going to be 1 over omega phi of 0. Since omega is equal to 2 phi f, we can rewrite this as 1 over 2 phi f omega of 0, phi of 0. So that's the answer. And this one is basically equal to 1 over omega, 1 over 2 phi. Instead of f right here, we can put delta of, is the same thing. And that's what they ask us to prove. Delta of omega is equal to 1 over 2 phi delta of f, and this one is f, not 1 over 2 phi delta of f. Okay, so therefore you can say, mention it here as well, delta of omega is equal to 1 over 2 phi delta of f. Okay, and that's basically it. That's basically what we had to prove. We have proven this, and also we have derived this. And that's it for this video. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on